Okay, coordinates and nature of each of the stationary points. So then state what the condition is for stationary points. Stationary points occur when dy by dx is equal to 0. So find dy by dx. So x cubed goes to 3x squared minus 3x squared will go to 6x minus 9x to minus 9, and differentiating 14 is 0. So there's my expression dy by dx. So now solve that equal to 0. So 3x squared minus 6x minus 9 equals 0. 3 is a common factor, so I'll divide by 3. So x squared minus 2x minus 3 is equal to 0. Factorise. So x in each little times to get 3, so 3 and 1, and I want a minus 2, so it'll be minus 3 plus 1. So that'll give me that x is equal to 3, or x is minus 1. So there's the two x values of the stationary points. So the stationary points will be 3 something and minus 1 something. Now then, to find these values of y, the corresponding values of y at these x values, I substitute these x values into my y equation. So y is x cubed minus 3x squared minus 9x plus 14. So if x is 3, then y is 3 cubed minus 3 times 3 squared minus 9 times 3 add 14. 3 cubed is 27, minus 3 squared is 9, minus 3 is 27, minus 9 3's add 14. So 27 taken 7 is 0, so we got minus 27 add 14, so that's minus 13. So it's 3, it's minus 13. If x is minus 1, then y is cube of minus 1, minus 3 lots of the square, minus 1, minus 9 lots of minus 1, add 14. Okay, cube minus 1 is minus 1. Square minus 1 is plus 1, times minus 3 is minus 3. Minus 9 times minus 1 is plus 9, plus 14. So y will be 14, 9, that's 23, take away 3 is 20, take away 1 is 19. So there's the stationary points. Now then, to get the nature, I'm going to use the second derivative. So I differentiate my dy by dx. So differentiate in 3x squared, that's 6x. Differentiate minus 6x is minus 6, and differentiate 9 is 0. So now I test, that's 3, so if x is 3, the second derivative is 18 minus 6, 6 3 is 18, which is 12, so that's positive, so that gives me a minimum when x is 3. And then if x equals minus 1, the second derivative is 6 times minus 1 is minus 6, which is minus 12, so that's negative, so that's the maximum at minus 1. So minus 1, 19 is a maximum. So there's the two stationary points together with a nature. Then part B wants me to sketch showing that. So I'll sketch that here. The axis x, y. So I got a minimum at 3 minus 13, so it's 3 minus 13, I got a minimum, and at minus 1, 19, I've got a maximum. So the curve will follow that then, so that will come all the way down, this one will come down to the minimum point, and then back up. So that's the shape of the graph. And then part C, the equation. So I've got that equation equal to k, which is what I've drawn, equal to k, has only one real root. Find the range of values. So to get one root, k is a horizontal line. So if I bring it, if I put the ruler there, I only cut it once. If I keep cutting it once until I come down to that maximum point. Then it's 2. Then when I bring it down, I got 3 points to cut in. 3 points to cut in until I hit the minimum when I've got 2 points to cut in. Bring that down further, then I'm only cutting once. So to get only one root, it needs to be above the maximum and it needs to be below the minimum. So k, for one root, k is have to be bigger than 19, or k has to be less than minus 13.